Okay, class, this is Coach Williams again, and this is the second video that we're doing as part of a review for our Unit 4 test, which is going to be on Thursday. We have already done 4.1, 4.2 in the previous video. We're going to cover 4.3 and 4.4. This is our homework check or quiz that we took in class. It's asking us in the beginning here to write two equations in standard form that are equivalent to the given equation. If you'll notice, this one actually is already in standard form, so if we want to just write what that is, standard form is ax plus by equals c. And so this one you can see is already in that form. Now, if we're going to write equivalent equations, we can do one of a couple things. We can multiply by something, or we could divide by something. In which case, we'll do one of each here to show you that how to do each one of those operations. When you multiply or divide, you have to remember that you have to multiply or divide every term in the equation. So if we're going to multiply by 2, we'll say, all right, well, multiplying by 2 means that we're going to have to multiply the first term by 2, the second term by 2, and the last term by 2, which is going to be a 3. So 3 times 2 would be 6. So we have 2 times 1x would be 2x. 2 times negative 9 is going to be negative 18y. And then 2 times the 3 is going to be 6. And this is an equivalent equation. This could be simplified or reduced back down to this equation. And so it is equivalent to that one. If we wanted to divide by 2, then we would divide the first term by 2. So that would just be x over 2. The next term we would divide by 2. And so again, we just put it over 2. And then the last term we would also divide by 2. So every term is divided by 2. You could also rewrite the first one as 1/2 x if you wanted to, 9/2 y, and then 3/2. Now it says write two equations. You could have divided by both times. You could have multiplied both times. So maybe you could have multiplied by 2 and then multiplied by 3, or you could have divided by 2, divided by 3. Any number you choose is fine. It's just make sure that you do it to every term, and you don't have to make it and multiplication and division examples. You can actually just do both multiplication or both division or one of each. Again, those are all still equivalent equations, and we're just asking for 2. So that's answer to number 1. On to the next problem here. Write an equation in standard form. Once again, ax plus by equals c of the line that passes through the given point and has the given slope. All right, so the first thing that we're going to need to do is have some type of form that we can throw all of this data into, and then hopefully rearrange it and get it into standard form. We have a point slope form, that is y minus y1 is equal to m times x minus x1. So we have this form here. This is our point slope form, in which case we are given a point and a slope, so we can put it into this form, and then we can change that form to be our ax plus by equal to c. So we can rearrange things and get to that form. So let's begin by putting this in. Y minus a negative 3. This is my y1. This is my x1. This is our only point, so this is my y value of the point and my x value of the point. It's going to be equal to 2 times x minus the x1 value, which is a 5. Okay. We're going to clean this up a little bit. This side will become y plus 3. This side, once we distribute the 2 in, we'll have 2x minus 10. We're going to have to rearrange this. Like we said, we need to get to this form. So we need our x on the left side. We need our integers on the right. So let's move the 3 from this side to this side. So we're going to subtract 3 from both sides. And I'm just going to put it on the end here for now. This becomes 0, goes away. So y is going to equal 2x minus, when I combine these terms, I'm going to end up with 13. So combine those terms, I get a 13, negative 13. All right, and now we're going to subtract 2x from both sides. And so this will become a 0, and our final simplified version here in standard form is going to be negative 2x plus y equal to a negative 13. Again, I just move this this 2x over here by subtracting it from both sides and just put it down in front here, leaving the y as a positive y there. So this is our standard form of the line that passes through this point with that slope. Okay, moving on to number 3. Number 3 gives us a graph, and you can see on the graph they give us 2 points. What's interesting about the graph too, some students have been clever enough to figure out too, they've also given us the y-intercept. So without having to put this in point slope form and change it to standard form, some of you have been clever enough to find the slope and use the y-intercept located here to go ahead and drop that into the form. We'll show you that short version real quick. This is our y-intercept. It crosses the y-axis right here. So this is at point 1, 2, 3, 4, 5, 6, 7. So we know that b is equal to 7. And now we need to find our slope. We can either find it by m equals y2 minus y1 over x2 minus x1, or we can just count from the left point to the right point, going up and down first. We're going to go up 2 over 1, so the slope is just a positive 2. We have our b, we have our y. We can write this in standard form. Actually, we're going to have to write this in point slope form using these 2 points here. We're going to choose 1 point. We're going to choose 1 point. If we choose 1 point, then we can have, well, actually, I tell you what, we could do it both ways. We'll start with the slope-intercept form. We would have y equals 2x plus 7 if we choose this slope and that y-intercept. And then all we'd have to do is just move this across to the other side. We mentioned something in class the other day about moving. Instead of trying to subtract or add across the equal sign, if we understand the concept, if we move a term to the other side of the equal sign, it just changes the sign of the term itself. Then we can just simply rewrite this as negative 2x plus y is equal to 7. Knowing that we really are subtracting 2x from this side, subtracting 2x from this side. So this is the answer, but let's use the point slope form to confirm. We'll pick the first point that's right here. We're going to pick negative 2 and 3. So we know that y minus the y value, which is a 3, is going to equal the slope that we found, 2 over 1, 2 times x minus the x value, which is a negative 2. Okay, so now if I simplify this here, we're going to have y minus a 3 is going to equal 2 times this term, which is 2x, and this becomes plus, so then it's just 2 times 2, which is 4. If you'll notice here, I can move this 2x to this side, which again just changes the sign. So I have a negative 2x plus y, and that one goes away. If I move the negative 3 to the other side, remember it just changes the sign. So I can add 3 to both sides, and if I add 3 to the 4, I end up with 7. And once again, I have the same equation in standard form of the line that's shown here on the graph. All right, on number 4 and 5, we're writing the equations of the horizontal and vertical lines that pass through the given point. This should be pretty simple once we grasp the concept of what a horizontal and vertical lines are and what their equations look like. Anytime you have a horizontal line, you're going to have y equals some value. Anytime you have a vertical line, you're going to have x equals some value. Because if x equals a value, you're going to have a vertical line looking like this. Anytime y equals a value, you're going to have a line that looks like this. Because everywhere along this line, y will have the same value, and everywhere along a vertical line, x would have the same value coming from the y-axis. It would have the same value as you moved up and down the line there. So if you know that that's the case, and you have this point, then you know that a horizontal line would have to pass through that 1. And if it's horizontal, then the horizontal line would be y equals 1. And that would be the equation of the horizontal line that passed through this point. It also has an x value of 4. So if I want the vertical line, then the x value would be a 4. X equals 4 would give you the vertical line passing through that point. We can just draw an arrow to that so you know that's where that's going. On number 5, again, the horizontal is going to be the y value, so y is going to equal a -2. And the vertical line is where it passes through this point where the x value is 10. So every value of x will be 10 on a line that just goes vertically through 10. And so we'll have x equal 10 will be the equation of the vertical line for this point 10, -2. And we'll write in little question marks here just in case you want to, you could put any value in those and you'll have horizontal and vertical lines. Okay, let's flip the page. On to the back, we're going to have another graph, but this time they give us a standard form and they want us to find the missing coefficient. Once we find it, they also want us to write the completed equation. All right, so they give us a point on the line, which is key to solving this equation, or for the values of this equation. They give us an x value of 1 and a y value of 2. All right, so if they give us the x and y values of 1 and 2, I could just simply take those values, plug them into the given equation, and then that will only leave me with one variable to solve for, and that's a. So let's do that. We're going to have a times x. Well, x is 1. And then we're going to add to that 2 times y, and y is a value of 2. And that's all going to equal 7. So now, if I solve for a in this case, then I can solve for the missing coefficient. A times 1 is just simply a. 2 times 2 is going to be 4. And 7 is still what both of those added together will equal. I will subtract 4 from both sides, and we're going to find out that a is going to equal a positive 3. Now with a equaling a positive 3, that is the value of the missing coefficient, and the completed equation would be 3x plus 2y equal to 7. So there we have our missing coefficient, and there we have our completed or filled in equation with the coefficient there. Okay, moving along, we're going to go to number 7, and number 7 is going to deal with parallel lines. Anytime you see in the instructions here parallel or perpendicular, I like to do this. Parallel, same slope. Okay, parallel means the same slope. So can I find any lines with these points here, and I can find the slope with 2 points. Can I find any lines that have the same slope? Parallel means the same slope. All right, so if I'm looking at line A, I'm going to find the slope of line A. I want to say m is going to equal, and we find the slope with 2 points using the y2 minus y1 all over x2 minus x1. And in doing that, for point 1, we'll have 3 minus 1 all over 1 minus a negative 1. All right, so then, if we take 3 and we minus a 1, we're going to get 2. We take 1 minus a negative means we're going to have a positive 2. And so the slope here is going to be 1. For line B, we have m is equal to 2. I'm going to skip the formula. We know the formula by now. 2 minus 4 all over 0 minus 3. So here we're going to have a negative 2 on top, a negative 3 on the bottom, and that just becomes a positive 2 over 3. For line C, we're going to have m equal to 3 minus 1 on the top. On the bottom, 3 minus 0, which is going to simplify to 2 over 3. Now, do any of these look the same? And yes, these two are the same. And if they're the same slope, that means they're parallel. So we can write this as line B is parallel to line C. This little symbol here just means that they are parallel. All right, let's move on to number 8. Number 8, write an equation of the line that passes through the given point and is parallel to the given line. Again, parallel. Same slope. Okay, so what is the slope of the given line? This is my given line. What's my slope? Some people may say, oh, well, it's 2, coach. Look right there in front of the x is a 2. But we don't have this in slope-intercept form because there's a coefficient in front of y. We're going to have to do a little work to find the slope. So to do that, we'll have to divide by 3 on both sides. So y is going to equal 2 divided by 3, x, minus the 1 divided by 3, because again, we're multiplying or dividing every term by 3 so that we can get y by itself. Now, it really doesn't matter what this term ends up being. All we're really concerned about is what is in front of x at this point, and it's 2/3. So my slope is equal to 2/3. All right, now, are we going to keep the same slope? Yes, because we're looking for something parallel. Had this been perpendicular, we would have to flip the slope and do the opposite sign, so it would be the opposite reciprocal. But this is parallel, so this is the slope we're looking for. Now, we're going to use this slope, and we want it to pass through this point. So we've already seen it before, but we're going to use the point slope form to create this equation, which is y minus y1 equal to m times x minus x1. All right, so using this form, y minus the y value, which is a negative 5, is going to be equal to 2/3 times x minus 3. And some of you may be saying, oh my goodness, coach, there's a fraction in here. But it's okay. It's not a big deal. We can work this out, no problems. Y minus a negative 5 is going to be y plus 5. Okay? And then 2/3 times x is just simply 2/3 x. Now, over here on the side, I'm going to do this for us. 2/3 times, because we have to distribute this into this parentheses here, 2/3 times a negative 3. Well, just don't worry about the negative for now. What is 2 over 3 times 3? We'll call it over 1. Well, 2 times 3 is 6, and 6 will be over 3 times 1, which is 3. That's just simply 2. All right? So 2 is what 2/3 times 3 is. Now it's negative because we do have the negative sign. So 2/3 x minus 2. Now, it wants us to write this equation. At this point, all I'm going to do is just get this in slope-intercept form. So I'm going to subtract 5 from both sides. This will go away, and y is going to equal 2/3 x. Negative 2, negative 5, make a negative 7. And there is my equation in slope-intercept form of a line that passes through this point parallel to the given line here. 2/3 x minus 7. Okay, let's move on to number 9. Determine which of the lines, if any, are parallel or perpendicular. So now we're going to look for same slope or perpendicular, which means opposite reciprocal. Opposite reciprocal. Okay, so the slope will be an opposite reciprocal, or it's parallel, meaning that's the same slope. And they also make it a little more difficult for us because they don't give us points. We're going to have to rearrange these and find the slope. Now the first one's easy. It's in slope-intercept form. So this one has a slope of a -4. This one looks like it's in slope-intercept form, but you notice the y is on the wrong side and the x is also on the wrong side. So we've got to change positions for those. Now that's real simple. Remember, we talked about just moving things across the equation or the equal sign. So if we take the 4y across over here and the x over there, we're just going to change the sign. So line B is going to be a -4y equal to -x plus 2. Okay, we just moved those two across the equal sign, which changed the sign. And if you want to look at it, in the usual way of seeing it, it's -4y or -4y from this side, -4y from that side, minus x from this side, minus x from this side, and there we get this again. Now we're going to divide by -4. And divide by -4, and divide by -4. Again, we're not real concerned about this last term because it doesn't really matter. All we really want to see is what is this in front of the x term. And negative over negative is going to be positive, but what is in front of an x? There's always a 1 there. So negative over negative is positive, so we have 1 over 4 is our slope. 1 divided by 4 will be our slope. Negative over negative is positive. 1 over 4 is what's in front of x. Line C. Again, we need to move this to the other side. It's positive, so we make it negative. We're going to have a -4y equal to a -x again, plus 3. This is going to be line C. Once more, we're going to divide by -4, divide by -4, divide by -4. This term doesn't count, doesn't really matter to us. And once again, we have in front of x a -1, and negative over negative is positive, and so the slope that's in front here is again going to be a positive 1/4. Now, this is real simple to see that these two are the same. So we know that line B is parallel to line C for a fact. But don't stop there. Look what we have right here. Isn't this 4 over 1? And -4 over 1 is an opposite reciprocal of 1 over 4 and 1 over 4. So we've got an AND statement here that we need to make sure we include. Line A is perpendicular to lines, and I'm going to put it in plural here, lines B and C. Because if you notice, if it's perpendicular to one line and another line's parallel, then it has to be perpendicular to the other line. So line A is perpendicular to lines B and C, and line B is parallel to line C. All right, that should be your answer for number 9. Let's flip the page. All right, on number 10, it says write an equation of the line that passes through the given point and is perpendicular to the given line. Once again, underline perpendicular to the given line. That means we're going to have an opposite reciprocal. Oh, whoops, I misspelled that. Reciprocal. Opposite reciprocal. Okay, so this here we're looking at, we find this is a negative in front of that. So the current slope is a negative 3 over 5. The perpendicular to that slope is going to be a positive 5 over 3. And this is a slope we need to use. So the existing slope is a negative 3 over 5. Perpendicular to that slope will be a 5 over 3. We flip it and we change the sign. So now, taking this and our point, y minus 1 is going to equal 5 over 3 times x minus 6. Again, don't panic because of the fraction. We're okay. Y minus 1 is going to equal 5 over 3 times x and times 6. So 5 over 3x. And then minus, and we'll do this off to the side again over here, 5 over 3 times 6 over 1, right? We can always put it over 1. 5 times 6 is 30. 3 times 1 is 3. 30 divided by 3 is going to be 10. So we'll use that for the last term here. All right, don't ever panic. Pull it off to the side and do it if you have to, or put it in the calculator. You should be able to figure it out on a calculator without any worries of fractions. Now, I need to add 1 to both sides. So we'll add a 1 to this. This will become 0. So our equation is going to be equal to y equals 5 over 3x minus negative 10 plus 1 is a minus 9. All right, and that is your equation of the line that passes through the given point perpendicular to this given line here. All right, the last two problems on here are asking us to write an equation of a line that is parallel to the given line A and perpendicular to the given line B. We talked about this a little bit earlier. If it's going to be parallel, then it needs to have the same slope. And in this case, we have a horizontal line. Y equals is a horizontal line. So to create a line that's got the same slope, which means this is a slope of 0, okay? If we have something that's going to be a slope of 0, we just got to create another horizontal line. So to create a horizontal line or a parallel line, another horizontal line, we're going to say y is going to equal some other constant besides 7. Remember that if you're going to make a line parallel to another one, it cannot have the same or pass through the same point if it's horizontal. So it can't equal 7. It just has to equal something different other than 7. So in this case, we'll just say y equals 4. And y equals 4 is a horizontal line that is parallel to this horizontal line, y equals 7. Now, for part B, something that's perpendicular to a horizontal line is a vertical line. All horizontal lines are perpendicular to vertical lines. So we've got to choose an x value, and at this point the x value can be anything because any vertical line will be horizontal to y equals 7. And again, we can just choose 4. We could have chosen 3 or 10 or negative 1. It wouldn't matter. As long as it's x equals some value, we'll have a vertical line which will be perpendicular to this horizontal line. All right, on number 12, they want to see if you're paying attention. They begin with a vertical line. Okay, so this is vertical. So another vertical line would have the same slope or be parallel to this vertical line. So part A, we need another x value or another, vertical line, equation of vertical line. So we need another value here besides 12 to know that we're going to be vertical or parallel to this vertical line of x equals 12. In this case, let's just choose 10. So x equals 10 is another vertical line. It's parallel to x equals 12. And part B, we need a horizontal line to be perpendicular. So again, we just say y equals, and we pick any value. At this point, it doesn't matter. We can say y equals 10. And y equals 10 will be perpendicular to the vertical line x equals 12. All right, I hope this has helped you. This has been the review for Chapter 4, and this particular section has been the review of the quiz 4344, and we will see you on the next video.